So the second piece of equipment I want to just go through quickly is what's called a photogate. The speed gate is for determining the speed, measuring the speed of an object. A photogate is entirely about timing. So we've got two photogates, and we connect them to this console here. One of them plugs into the start, one plugs into the stop. I've not connected them because it's a bit involved to do so, but once we connect them, there'll be a laser beam that goes across here. Now as soon as that laser beam gets broken for the start one, that starts a timer on here. And then this one would be connected to the stop, and as soon as that laser beam gets broken, then that would stop the timer. Now it'll actually time it accurate to 4 decimal places, so we can get very accurate times using the photogate. And the experiment that I use this for is when we measure how long it takes for an object to fall, because those times are very, very short. So the photogate really comes in handy for measuring times that are especially less than 1 second. In the old days, what we would do, let's say we wanted to measure how long it took this golf ball to hit the ground. You're dropping it from about 1.5 meters, and it would take it maybe 0.6 seconds in order for it to fall. 0.6 seconds, but if I had a stopwatch, and it's going to take me, it's going to be a bit of delay to start the stopwatch when I first drop it. It's not going to be completely precise. And it's going to hit the ground, and as it hits the ground I have to stop it. Again, there's a reaction time there. It's not going to be entirely precise. So even if my measurement is quite good, which it means is, let's say, off by 0.2 seconds, that would be quite good. 0.2 seconds, when it's only falling for 0.6 seconds, that's 33% error right there in that measurement. So with a longer time interval, 0.2 seconds is really nothing, but you're measuring things that are very, very short. That 0.2 seconds could mean that your results are quite different than what they actually should be. So the experiment that I designed, I actually created this tube, sort of telescopic. It's just A3 poster paper, and you can basically extend it quite a ways. And to show you how I do this, so I would take one of the photogates and I would put it on the ground. Then I would put the tube on top of it, and I would put the second photogate on the top, like so. Let's just move that up a little bit. Something like that. So I would drop the ball. As soon as it breaks this first beam, it would start the timer. Then it's going to go down. It's going to fall through the tube, and the tube just ensures that it passes through the second photogate and breaks that beam. And as soon as it does that, that's going to stop the timer, and we get a time that is accurate to 4 decimal places, which is much better than we could do if we were doing it with a stopwatch. So that's the importance of the tube. If I were to, I've actually tried to do it before without the tube, and it's very difficult, even let's say when the two photogates are, let's say, only 1.5 meters apart. Even if they're just a short distance apart like this, it's very difficult to actually drop an object so that it passes through the beam of the first one, and then it continues on to pass through the beam of the second one. So the tube just helps guide the ball down so it passes through that second gate and stops the time when it's supposed to.